Course 3, Lesson 87, and we are looking at scale drawing word problems. So in this lesson, we are thinking about, well, if we have this relationship between actual dimensions and the drawing of the dimensions, what can we do to go back and forth? So let's start looking at this. Alright, with scale drawings, we can determine how far it is from one place to the next on a map or a picture. So we're thinking about, well, if we have an atlas or if we have the blueprints for a house, those are drawings of things that are in real life. But of course, we're not actually going to have a piece of paper that big. We're going to scale them down so that we can see them all in one place, right? So if the map says that for every 1 inch, there's really 10 miles, that means if we go 2 inches, that's 20 miles. 3 inches would give you 30 miles. Okay? Let's see if my pen can work. We would go 30 miles. So we can go back and forth between these different dimensions. If we know that in real life, from one town to the next it's 50 miles, well then on a map it would be 5 inches in this case. So let's try one using a specific scale. So Mary sketched a scale drawing of her dream garden using 1 inch to represent 2 feet. If the drawing of the garden is 8 inches long, how long would the actual garden be? So one of our tools that we can use for these type of problems, and you may know already how long it's going to be in real life, but if we are struggling with that, then this is a tool that can help. First, we have a box with columns that talk about scale and talk about measure. And in the first row, we talk about the drawing in inches. We know that the scale is 1 inch to 2 feet. Okay, the garden in feet is the 2 part of our scale. We also know that in the drawing we have 8 inches. So we can use this to set up a proportion, saying we have this scale of 1 to 2, and that's equal to 8 in reality over the length of the garden. Okay, so with this proportion, we can use cross multiplication to solve, or any other method that works with a proportion. But if we cross multiply, we can see that we get 1 times L is L, and 8 times 2 is 16. So our length for the garden in real life is 16 feet. Now this method is going to work for a lot of different things. So let's look at another example of how this is going to work. And I'll just use this same scale. But let's say we have our scale, we have our measure. We still have 1 to 2, so 1 for the drawing in inches, and for the garden in feet. Let's say the garden is 20 feet in reality. Well, what is the measure in the drawing? Well, we can set up our proportion again. 1 over 2 is equal to x over 20. And we cross multiply. 1 times 20 is 20. X times 2 is 2x. Those equal each other. We divide by 2 and see that in our drawing, that length would be 10 inches. So it can go back and forth, whether we are given information about the drawing or if we're given information about the real life length. So, same idea. If the garden is to be 12 feet wide, how wide should the drawing be? So this is just like what we did in the other one. Our scale, 1 to 2. Our garden is 12 feet, and we set up our proportion. So if we go and cross multiply, 1 times 12 is 12, 2 times w is 2w. We equal them, divide by 2 on each side, so that we get w alone as 6. So the drawing is going to be 6 inches wide. All right, let's keep going. Let's look at a new concept. Let's try this one. So Larry wants to convert the attic to a living space. He has made a scale drawing 1 inch to 16 feet. What are the dimensions of the bedroom if the drawing shows to be 1 inch long and 3/4 inch wide? So we have this drawing on a piece of paper that is 1 inch to 3/4 4/4 of an inch. And we want to know, what is it going to be in reality? Well, we are going to need two different boxes set up for the scale and the measure, because we have two dimensions that we need to transfer. So first, our scale is 1 to 16, 1 inch for the drawing, and for the room in feet. For the measure, we are given information about the drawing, so we keep it in the row for the drawing, and we say, well, we have given that side length of 1, and we don't know this one. We can set a proportion. 1 over 16 is equal to 1 over x. We cross multiply, and we get x is equal to 16. And we do our second measure. Okay, so this is 16 feet. Now we need to know the other side length. We're going to do 1 to 16, same rows as before for our scale and measure, same columns, but instead of 1 inch, our side length is actually 3/4 of an inch. So we can say 1 to 16 is equal to 3/4 over x. We can cross multiply so that we get x is equal to, well, 16 times 3/4. That 16 we can put over 1 to show as a fraction. We can even do some simplifying. 4 goes into 4 once, 4 goes into 16 4 times. So we would get x is equal to 12. Okay, just 4 times 3. So we see that in reality, this room is going to be 16 feet by 12 feet. 16 feet by 12 feet, because that's what our drawing tells us, and we can use our scale to convert. Now let's try this other one. Different room, 1 inch by 5/8 inches. Well, that 1 inch that we had before, that's not going to change. That's still going to be 16 feet in reality. The question is the 5/8. So we already know we have 16 feet by something, and we just have to convert the 5/8. So the scale stays the same, 1 to 16. This is in inches, and this is in feet. So we know more information about the inches, 5/8. We're going to put x because that's the part we don't know. And we're going to set up a proportion. 1 to 16 is the same as 5/8 over x. Let's multiply so that we get x is equal to 16 over 1 times 5 over 8. We can simplify 1 and 2 so that we get x is 10. So the dimensions of that room are going to be 16 feet by 10 feet. Okay? Let's look at another one. A map is drawn with a scale of 1 inch to 8 miles. Two towns are 2 3/4 inches apart on the map. How far apart are they really? So let's set up our table. We have our scale and our measure, and our ratio is 1 inch on the map to 8 miles in reality. We are given information about the drawing, so 2 3/4 inches. But we don't know how far it is in reality. So let's set up a proportion. 1 to 8 is equal to 2 3/4 over x. And we cross multiply so that we get x is equal to 8 times 2 3/4. Well, to be able to multiply those, I'm going to put them as fractions. 8 over 1, and I'm going to convert that 2 3/4 into an improper fraction. So we have 4 times 2, which is 8, plus 3, 11 over 4. We can simplify to 1 and 2. This gives me 22, meaning that these two towns are 22 miles apart. Similarly, same scale, but now two cities are 5 7/8 inches apart. Same scale, 1 to 8, but now we have 5 7/8. We set up a proportion. 1 over 8 is equal to 5 7/8 over x. And we cross multiply. X is equal to 8 over 1 times, well, 5 7/8 as an improper fraction is going to be 8 times 5, which is 40, plus 7, 47 over 8. The 8's cancel out, and we find that those two towns are 47 miles apart. Okay, now let's think about these two problems, and we're given lots of information about the drawing, but what if we don't have information about the drawing and we just have information about reality? So I'm going to erase this for now, and I'm going to make up another question. Let's say that we know that we're going on a trip, and we know that the towns are 84 miles apart. What would that look like on the map? Well, we can do this still with our table, our scale and our measure. And in this case, we're going to say they stay the same. Okay, we're in the same situation. But instead of putting information about the drawing in that box, we have information about reality. So 84 miles. And we put our x here. And we set up our proportion. 1/8 is equal to x over 84. So we cross multiply and get 84 is equal to 8x, and divide by 8. When we divide by 8, we see that x is 10.5 inches. On a map, those two towns would be 10.5 inches apart. So depending on the information that you are given, just fill in your box appropriately. Last example. Mariah is making a scale drawing of her apartment. Her apartment measures 36 feet long and 30 feet wide. She wants the drawing to fit on an 8.5 by 11 piece of paper. Which of the following would be a good scale for her to use? So 1 inch to 2 feet. Well, if we use this, we will see that 1 inch to 2 feet, so for every 2 feet, it's 1 inch. So for that 36 feet, it's going to be 18 inches. And for the 30 feet, it's going to be 15 inches. Well, unfortunately, that is too big for our page, so that one's not going to work. 1 inch to 3 feet. Okay, well, if we put that in, 36 feet is going to become 12 inches. The 30 feet is going to be 10 inches. Unfortunately, that one is too big as well. 1 inch to 4 feet. The 36 feet is going to be 9 inches on the drawing, and the 30 feet, well, 30 divided by 4 is about 7.5 inches. Although really large, it would actually fit on the page. It would just be a really big drawing, so that is a possibility. And lastly, 1 inch to 6 feet would be 6 inches by 5 inches. Also would fit on the page. Depends on what she wants to do with this drawing. If she wants to be able to label it really well, put lots of things like her couch, her lamp, maybe where her TV sits, then maybe she needs a bigger picture like the 1 inch to 4 feet. Or maybe she just wants the dimensions of the room, and it's okay that she doesn't have a really big picture. So she just puts it as 1 inch to 6 feet. Well, I hope this was helpful for your homework and for studying.